Yes, ladies and gentlemen, Oscar and Felix are here. This is Mr. Bryce with Susquehanna Valley High School here in Concord, New York. There's my email address. We're doing Unit 7, Lesson 5, Even and Odd Functions. Common Core Algebra 2, non-Regents version. So we're going to be talking about functions, even and odd functions. And remember that functions are simply rules that convert inputs into an output. So an even function and an odd function. An even function is if the function evaluated at negative x equals the function evaluated at x for every value of x in the domain. An odd function is if the function evaluated at negative x equals the negative of the function evaluated at x for every number in the domain. That's kind of tough to understand. It's a good idea to be able to read mathematical definitions. So I want you to write that down. Okay, now you can write it down. A reflection across the y-axis. What does that mean? Opposite inputs give the same output. So if we input negative 8, it equals the input of 8. For example, if negative 8 has an output of 12, then 8 must have an output of 12. You understand that if negative 8 has an output of 12, then positive 8 has to have an output of 12. And simply, it means the point negative 8, 12 has to have the same thing as 8, 12. Never, never, never 10 and 10. Okay, those are the same x's having different outputs. No, that isn't what it means. Okay, so what about an odd function? It's two reflections. Okay, the first is across the y-axis and the second is across the x-axis. Opposite inputs give opposite outputs. What? The function value at negative 2 equals the negative function value of 2. I don't quite understand that. So here's an example. If you input negative 2 and it equals 27, and then you input 2 has to equal negative 27. Oh, more familiar terms. Negative 2 throws out a 27. Positive 2 throws out a negative 27. Positive 27, negative 27. Positive 2, negative 2. Oh, got it. The x and y change signs. Let's take a look at even and odd functions from a graphical point of view. So this is asking us, here's an even function and it only graphed part of it. What does the other part look like? So we've got to graph the other part. Always keep in mind that if we have negative 8, the output is 12. Then we have positive 8, the output is 12. So let me see here. I have 3, the output is 5. That must mean I have to have negative 3. Remember, only x's are changing for even. I have to have negative 3, and the output is 5. Okay, I think I got it. Write down the point 3, 5, and that's going to change to negative 3, 5. What about the point 7, 2? The point 7, 2 is going to change to negative 7, 2. So let me see if that was plotted correctly. It says 7, negative 2 goes to negative 7, negative 2. There we go. So let me plot the 2 points. So 3, 5 turns into negative 3, 5. Negative 7, 2. Sorry, 7, negative 2 turns into negative 7, negative 2. Oh, it is a reflection across the y-axis. Okay. Now, the point 0, 0 turns into negative 0, 0, which is just 0, 0 again. Let me connect them. And there we go. Now here with an odd function, taking a look at it, 3, 5 has to give opposite inputs, gives an opposite output. 7, -2, opposite input, gives an opposite output. 0, 0, opposite input, gives an opposite output. Well, of course, -0, 0 is just same as 0, 0. Let me plot those points. Now, the order in which you connect them is important. Okay, so the first one we go to 0, 0, then here, then there. This is a rotation of 180 degrees. Okay, got it? Let's take a look at the next problem. Part C of this question says, describe the symmetry of the even graph and the odd graph. So I already said it. An even reflects across the y-axis. An odd is 180-degree rotation. Some people say that's a reflection across the origin. Let's turn to the next page. Okay, while this question for exercise number 3 is good, I'm going to just change it a little bit, and instead of plugging in some numbers, we're going to try to plug in some variables. So remember, for an even function, for question number A, is it even or odd? We have to understand that f of x has to equal f of -x. So let's do that. F of x equals the absolute value of x minus 4. Okay, so what are we really doing? F of -x equals the absolute value of -x minus 4. What's the absolute value of -x? Oh, that's just absolute value of x, which is also just, x without a, if x is positive, then it's positive. If x is negative, then it's the opposite, it's positive. What I want you to take a look at is the fact that these equal each other. It is even. Algebraically proven. Without the use of a calculator, please graph those. Okay, let me see. Inside parentheses move left or right, nothing inside. Outside parentheses move up or down in the same direction. So it's -4, -1, -2, -3, -4. And it's an absolute value function with a slope of 1 and a slope of -1, because there's no number in front of touching the absolute value. So there is f of x equals the absolute value of x minus 4. Does it look like it reflects across the y-axis? Absolutely. So it is confirmed as an even function. Okay, so higher order polynomials, polynomial degree 3, right here, a cubic. What I did was I already filled in the table. So you go ahead and hit pause and fill in the table. Now, what's an odd function? Well, an odd function, we have opposite inputs gives opposite outputs. So far, so good. Opposite inputs give opposite outputs. Well, is the opposite of 0, 0? Yes, because it's on the opposite side of the number line is 0. 0 is the flipping point. So here, -1 and 1 give out 3 and -3. Good. So we have opposite inputs equal opposite outputs. This is an odd function. Sketch and graph using your calculator in the window indicated. Okay, so it crosses right around 2, negative 2, sorry, goes through 0, goes through positive 2, and up. Is the function f of x equals 2 to the x odd, even, or neither? Support it with numerical evidence. First of all, let's understand that we recognize this as being an exponential function. And it's increasing exponential function. We know that there's no symmetry across the y-axis. We know it's not odd. We know it's not even. So let's first try to see if it's neither. The even function test. F of negative x has to equal f of x. So does 2 to the negative x equal 2 to the x? Remember the negative exponent rule. Does 1 over 2 to the x equal 2 to the x? The only time that that's true is when x equals 0. All other numbers, it's false. So, for instance, if I were to substitute the number 1 in there, no, because 1 over 2 to the first does not equal 2 to the first. So now let's do the odd function test. Opposite inputs give opposite outputs. So here we're going to say 2 to the negative x has to equal negative 2 to the x. Let me see. If I just plug in the number 3, 1 over 8 does not equal negative 8. No, not odd. So it's not even and it's not odd. It's neither. Okay, finish the packet and we will be done with the packet. Hand it in and I'll grade it. If you have any questions, just ask. Bye.